Let's look at the four-stroke cycle for a typical gasoline engine. The air-fuel mixture enters the cylinder, is compressed, ignited, the resulting combustion creates pressure, forcing the piston downward, turning the crankshaft. The spent gases are expelled, and the cycle repeats. The four-stroke system of operation consists of an intake stroke, compression stroke, power stroke, and exhaust stroke. One stroke is counted each time the piston moves the entire length of the cylinder. The term four-stroke engine is used because the piston moves up and down the cylinder 4 times in one cycle. The intake stroke begins with the intake and exhaust valves open. As the piston begins its downward stroke, the exhaust valve closes. Downward travel of the piston increases the volume of the cylinder and creates a low-pressure area. The pressure difference between the intake manifold and the cylinder causes the mixture to flow into the cylinder. As the piston reaches the bottom of the stroke, air and fuel continue to enter the cylinder due to the inertia of the incoming mixture. A throttle plate is used at the air intake of the engine to control the amount of air allowed to enter the engine. While the engine is idling, the throttle plate is closed. During closed throttle operation, a minimal amount of atmospheric pressure is allowed to enter the engine. Because a low-pressure area is created during each cylinder's intake stroke, a pressure differential occurs within the cylinder between atmospheric pressure and low pressure, which is known as vacuum. Vacuum is high, 58 to 75 kPa or 17 to 22 inches Hg at idle with the throttle closed. The compression stroke starts as the piston begins upward movement. Inertia of the incoming air-fuel mixture continues to fill the cylinder. Shortly after the piston passes bottom dead center or BDC, the intake valve closes. As the piston moves upward, the volume of the cylinder decreases, raising the pressure and temperature of the air-fuel mixture. As the piston nears the top of the compression stroke, the mixture is ignited by a spark from the ignition system. The power stroke begins as the piston starts its downward movement. Cylinder pressure increases rapidly due to the combustion and expansion of the burning mixture, forcing the piston downward. The downward motion is transmitted through the connecting rod to the crankshaft, where it is converted to rotary motion. The exhaust valve is opened as the piston nears the bottom of the power stroke, allowing exhaust gases under high pressure to begin leaving the cylinder. The exhaust stroke begins with the piston at BDC and the exhaust valve already open. Upward travel of the piston forces the remaining gases out of the cylinder. As the piston nears the top of the exhaust stroke, the intake valve opens. The inertia of exiting exhaust gases creates a low-pressure area in the combustion chamber. As a result, the air-fuel mixture begins to fill the cylinder.